Ladies and gentlemen, welcome to Australia New South Wales Innovation Forum. We would like to thank you for your interest and participation today. First, we would like to welcome Investment New South Wales Trade and Investment Director, Mr. Lawrence Chang, to give us some opening remarks.
Thanks, everyone. Thanks for coming to today's Innovation Forum. This is a very important forum for the state of New South Wales. This is the first time we participate in InnoVEX. This year, we brought 4 companies with us to this event. We are just located outside in the InnoVEX pavilion at the S0712. We have quite a big pavilion. Please, after the forum, please come and see us at the, you can speak to our startups. And New South Wales, it's located in Australia, of course, and our capital is Sydney, and we have the largest population and the strongest economic growth. And we are a very innovative state. We are the most innovative state, may I say, in Australia. We have a very large ecosystem in Australia to foster ecosystem growth around the tech area. This year we have 4 companies join us. And if you guys are interested with New South Wales, please come and speak to me after the event. And this is the 4 companies we have today. We're going to have them come up to do a short presentation to showcase their technology to the Taiwanese audience. And this is what I do, provide market intelligence, connecting you with the relevant organization if you're interested to come to Australia as investment. We provide like a consultancy service to the Taiwanese company who are interested with the Australian market as an investor. And that's my contact detail. But don't worry, I'll hang around after the show. So feel free to come and see me. And we can exchange details if you want to know more about the state of New South Wales. Now I'll pass to Quantum Brilliance to do the presentation. Thank you.
Excellent. I just wanted to start off by thanking Lawrence and Investment New South Wales. They've just done an absolutely amazing job in introducing us to the Taiwanese market. So thank you very much, Lawrence. So my name is Mark. I'm the CEO and co-founder of Quantum Brilliance. And what we do at Quantum Brilliance is we use synthetic diamond to build quantum technology. So let's get right into it. So what you see on the screen here, which is that small piece of synthetic diamond you see here. This is the critical new semiconductor material that will transform classical electronic industry, but most importantly, quantum technology. Synthetic diamond is the only quantum material that is able to operate entirely under room temperature and be miniaturized. So I'll start off by talking about how we can make quantum computers anywhere and everywhere, and be deployed in all types of complex environment. So what can you do with a quantum computer? You can do quantum computers to do lots of amazing tasks that you can't use with a classical computer. However, one of the core challenges of being able to harness quantum computing technology is removing decoherence. Now, what causes decoherence? Decoherence is basically you've got a quantum state, but if you have pressure changes, temperature changes, that actually results in the state to collapse down to classical state. To remove decoherence, most companies use very large fridges, like the ones you see done by IBM and Google. This technology is called superconducting quantum computers. They basically have a quantum computing chip that sits at the very, very bottom underneath that fridge. They freeze it to below minus 273 degrees. And that's how you can maintain that quantum state for as long as possible. Other companies, they either build very, very large quantum computers. So for example, the ones companies like PsiQuantum is building is going to be the size of entire industrial warehouse. Or you have companies that's building room-sized quantum computing systems that is very, very big. For example, you got companies like IonQ and D-Wave. They're both listed on US stock exchange, valued at about $1.5 billion. They're making quantum computers that fits into the size of a large room. The reason why these quantum systems are very big is to remove decoherence, you either need to have complex lasers, very large fridges, or you need vacuum systems. The beauty about using synthetic diamond for our technology is we don't have to worry about any of that. And the reason is because we can manufacture the qubits on this piece of synthetic diamond, and once the qubit sits there, it just passively sits there forever. But most importantly, the qubits are being held by the carbon, and diamond is the strongest material that is known to mankind, so the qubit stays there forever. Now, if you can harness that qubit for quantum computing technology, you can then produce a quantum computer that is the size of my microphone here, and you can really build quantum accelerators that can be deployed anywhere and everywhere. And so our vision and our mission for the company is to produce quantum accelerators that can be mass deployed in any type of environment. And so this is our vision. This is the quantum accelerator that we want to get to. But the hardest part behind this technology is everything on the right-hand side here, which is how do you create functionalized quantum diamond material technology that has qubit architecture that you can prefabricate. And everything on the left-hand side is things that is relatively straightforward and has been the trillions of dollars that's been invested by the semiconductor industry in Taiwan, Malaysia, Singapore, Japan, Korea. So our technology's core intellectual property is how do you create useful quantum diamond. Now, if you can have a quantum computer that can be put anywhere, all of a sudden, you change the whole scope of your application. And so some of these companies you see at the top in terms of these key companies we've been working with. On the far left-hand side, we've been working with different types of defense organizations to look at edge signal processing and what is the advantage you can do with quantum computing at the edge. Turns out there's actually quite a bit because you can actually use quantum computers as co-processors, similar to how GPUs and CPUs are co-processors for OpenAI. You can also think about having not one quantum computer, but hundreds of quantum computers massively parallelized. And we're starting to discover that for quantum machine learning and computational chemistry, the more quantum computers you can massively parallelize, the less qubits, the less physical qubits you require in order to solve critical problems. So the scope of application for small compact quantum computer completely changes. People often ask me, what is the first application I see quantum computers do? We think it's quantum machine learning. And one of the key discoveries behind that is under adversarial attack. So if you have someone that tries to ingest noise in a classical neural network, that thing actually collapses quite fast. And it's actually quite dangerous, especially for edge systems. Whereas for quantum neural network, it's a very resilient system. So there's a Nature paper that's been published around that, and the results are really impressive. So we believe if you want faster training time and more accurate training for your machine learning edge systems, it will have to be a quantum system. And so this is some of the work we've been doing around robotics control as a small project to get started to see what you can do with it. Now, what have we done at Quantum Brilliance? What we've done is we were the world's first company to install the first generation quantum computer you see on the screen there. It's roughly 6U in size and about this long, and it only consumes 300 watts. And we basically were the world's first company to install a quantum computer and integrate it within supercomputing centers. Out of fun, last year we decided to put a quantum computer on a Hyundai electric vehicle just to see whether you can actually do quantum computing at the edge. Turns out that you can. At the end of the year, we're deploying the world's first cluster of quantum computers in one of the major US national laboratories because they see the benefits of massively parallelized quantum. Now, more broader than using diamond as a quantum computing technology, what we've uncovered is that it's actually very useful for other types of applications beyond computing, in particular quantum sensing. So what's emerged in the past 4 years especially is there is more and more large companies that have selected synthetic diamond for quantum technology. AWS have selected it to build the next generation quantum internet. You got Bosch, Google using it for new global navigational systems, using it for medical devices, for biomedical detection. And you got people like defense primes that are using to locate it, deploy onto satellites for better GNS. So more and more people are choosing synthetic diamond as that critical material. The market is quite big, and when you look at, say, the quantum computing market, computing industry is roughly $1 trillion, so that market size is not unimaginable. But the quantum sensing one is a market that is available today and now. Companies are building devices that can actually be mass deployed to transform sensors to become ubiquitous, because in order to have autonomous systems that are smarter, you need better sensor devices. So this is a prototype that Bosch built. It's the size of a credit card. And as you can see here, there's a piece of diamond that sits inside in order to make sensing a reality. The picture on the left is the first prototype that AWS has started to build for the next generation quantum internet. About Quantum Brilliance, who we are. So in order to build a quantum computer, this is or quantum sensor, you sort of need to do the same thing. You have to take a raw piece of synthetic diamond that we currently get out of UK and Japan. We then functionalize it, and then we do all the beautiful nanofab, microfab, device integration, and this is where I'm really excited about countries like Taiwan, where a lot of that device integration capability actually sits here in Taiwan. And then the final step is we deploy it. We've been working with NVIDIA and Oak Ridge National Labs to develop application stack to realize useful quantum applications. Now, if you build a quantum sensor, that value chain actually stays exactly the same as well. So we are Quantum Brilliance. We have about 85 people globally. We're a 4-year-old company, but it came out of 20 years of research out of University of Stuttgart and Australian National University. And we've secured about $50 million of contracts. That's allowed us to service sectors in defense, supercomputing sectors, and work with some of the world-leading blue chip partners in semiconductor industry to advance this critical material to be useful. So I think this is just bragging slides of VCs, but we've got products for quantum materials, quantum computing software and hardware, and we're backed by sovereign wealth funds in Australia and deep tech funds. Again, this is just, we've got revenue, and there's high revenue growth, but I think the key thing is we know that to realize quantum computing to become a mass scalable technology, we actually need to work with partners in semiconductor value chain sector. So I'd love to talk to you guys or your networks if you want to work with us in order to make it a reality, because even though we have the quantum the quantum architecture blueprint, the reality to realize this into a lower cost technology is to plug into existing semiconductor value chain. And that's why we're really keen to have a chat. The company is being co-founded by the 3 co-founders you see there. Marcus Daltrey, in particular, is a well-known quantum technologist. He's one of the founders that pioneered the field of diamond quantum materials. But we also have some amazing staff that is making this company a reality through their experience in semiconductor industry or working on an ARM or IBM. And we're really excited to bring quantum technology so that it becomes something that can be mass deployed, because only if you democratize quantum computing and quantum sensors to make it available can we really change the world. I believe any centralized hardware technology doesn't necessarily provide the benefits that we need for humanity. So we're very passionate about mass deploying quantum technology, and we know that synthetic diamond is the quantum material that can achieve that outcome. Okay, with that, I'll pass it back to Lawrence. Thanks very much for your attention.
Thank you, Mr. Luo. Next, we would like to invite Mr. John Livingston, founder and technical director of Cubetape, to share about mobile dimensioning and weight data capture equipment. Thank you.
Good afternoon, everyone. Can you all hear me? Yes. Good afternoon, everyone. I'm John Leveson. I'm one of the founders and COO of a Sydney-based company who are doing mobile dimensioning. And you may be asking, what's a mobile dimensioning business doing amongst artificial intelligence, quantum computing, and some of these other illustrious new technologies? And the answer is that people need to measure things. And if you're in the freight industry or you're in warehousing, or you're in shipping, dimensions are a critical part of moving freight around, and a critical piece of how you charge people. If you send an item from, say, Taipei to Sydney, almost certainly the charge is going to be based on the size of the package. So it means wherever you are in the supply chain, you actually need to dimension. And so we have a mobile dimensioning solution. And rather than me talk about it, I'm just going to show it to you. We might need volume on this, I don't know. Fantastic, thank you. So, a tape measure is often not enough. They have limited accuracy. There's lots of human error. If you use a tape measure and remember the dimensions and then walk to a computer and key the dimensions in, very likely you've forgotten what the dimensions are, and you can also make keyboard entries, keyboard errors. So this gets rid of that issue. Most of our customers use these devices to measure big, ugly freight as opposed to small packages, because there are no other solutions to do that other than manual. So the markets we're in, we empower warehouse managers, shippers, carriers to accurately measure any freight from anywhere and sending data directly into existing systems. So critically important, getting the data is one thing, you have to get it back into the system. So if you're in a freight company, you need to get the data, put the data into your back office system so you can then charge the right amount of money to your customers. And that's what people are using this thing for. So the two critical applications that we have our device, which is on the stand if anyone needs to come and see it. The C200S, used for revenue protection. And revenue protection means make sure you charge the customer the right amount of money so that you're actually not losing money on the transaction. And as I've said to a couple of people today, we have a large UK freight company that makes tens of thousands of pounds every week simply by measuring stuff. So it's extraordinarily valuable for them. So that's revenue protection is one of those applications. The other one we call master data, and this is the application whereby items that are arriving at a warehouse are measured on the way in. So we have some technical details I won't bore you with in terms of battery life, working temperatures, etc. If you're interested in these, then please come onto the stand later. So, as I've said, used to protect revenue, remove manual errors, and it's super easy to use. So if you're in a warehouse and you've got people measuring things who are paid on $10 an hour, it needs to be simple, which is part of the reason why some of the more complicated solutions just don't work. This is practical, and it's a practical way. So it's very ergonomic. It has a range of tape sizes. It's got Bluetooth connectivity to get the data and Wi-Fi. It's certified for use in most of the markets that care about that. And if you're interested, please come to the stand. Trusted by a whole lot of people around the world, and most of these names you will have seen or heard of, and so widely deployed across Europe and the US, and increasing interest, interestingly, in this part of the world and in developing markets. So that's, we have some interest in India and other places. So things are looking very interesting. So I'm going to skip over that. And please, if you're interested in more, please come to the stand. Thank you for your attention.
Thank you. Thank you, Mr. Livingston. Next, please welcome Mr. Frankie Yang, FAE Manager of Morse Micro, which will introduce us to Wi-Fi Hello chip.
Hello everyone, I'm Frankie from Morse Micro, but I would like to speak Mandarin in computers because we are in Taiwan. 各位好，我是 Frankie， 我是现场应用工程师，based on 台湾，我支持Morse Micro 这个新公司以及 WiFi Hello Technology。那首先我先介绍一下 Morse Micro。那我们公司成立于2016年，然后总部设在雪梨，澳洲。那目前我们是澳洲最大的无晶圆半导体公司。那目前我们有非常健全的投资者，以及非常好的政府支持，也谢谢 Brilliance 以及澳洲西南卫视澳洲。那目前来讲，我们在资金上也好，或者是晶圆上也好，都无虞，不用担心。然后目前我们在无论是这一代的晶片也好，甚至下一代未来的开发，我们都没有任何的疑虑，这个都可以放心。那目前来讲，我们提供给这个世界，我们提供了最小的晶片，也提供了最低功耗。那目前来讲，我们也是有一个将近160个雇员的一个公司人员遍布在全世界，各处都有。那目前讲，我们也提供至少在美国 FCC 认证以及 WiFi 联盟 WiFi logo 认证上面的一个方案。那目前我们是 WiFi 成员的这个组织。那如果各位如果对 WiFi Hello 有兴趣届时候如果有兴趣取得 WiFi 联盟的一些认证，也必须跟我们必须跟我们做一些对策，来取得 WiFi 联盟的一些认证以及 ID。那当然，我们希望在 WiFi 这个领域会能够成为IoT 这个世界里面 WiFi 最大的晶片供应商，这是我们的愿景。那聊一下我们公司的位置。那除了雪梨是我们的总部以外，目前我们在美国也有2个办公室，那其中也有业务以及一些 operation 的人员。那在英国、印度都有一些研发人员。那不免乎在 Great China， 包含中国、杭州、深圳以及台湾，我们都有 FAE Sales， 然后在支持我们的客户以及推广我们的 WiFi Hello 产品。那介绍一下什么是 WiFi Hello。那基本上它基于 IEEE 802.1H， 那一样跟我们公司创建时间一样是在2016年。那主要的目的是什么？第一个，它当然是支援长距离。以 WiFi Hello 的架构来讲，至少支援我们都是会称它是1公里以上的等级。那除了距离以外，我们有更好的穿透力相对传统 WiFi。那除此之外呢，我们可以提供更多的节点。那我们目前来讲，以流量值上看到8191个节点，这是我们针对 Legacy WiFi 所做不到的部分，我们做了一些加强。那功耗部分来讲，我们相较于传统 WiFi， 我们也提供更低的功耗。那当然就是这是非常适用于 IoT 的一些应用，以及一些电子方案的一些运行。那当然我们是 WiFi， 所以当然我们也支持一些IP， 包含 TCP/IP、IPv6、IPv4， 这是我们都当然支持的。那在安全性上面，我们也支持打 PSE， 这个是目前 WiFi 联盟主推的安全性加密机制。那简单的说，我们到底做了什么？我们就是提供给世界一个传统 WiFi 所没办法连线到的一个距离，这是我们的方案可以达到的。另外，我们也提供了长距离无线领域里面在那个行星下面所达不到的一些频宽，这是我们主要提供给世界这2个主要的功能就是 Legacy WiFi 做不到的距离，我们做得到。长距离 WiFi 目前长距离无线技术目前达不到的频宽，我们做得到，这是我们主要能够提供给世界的方案。那这是一个简单的说明，就是说目前无线世界里面大概有哪些方案？那当然大家最熟悉的就是 WiFi 4567，它有非常非常高的频宽，但是它的距离可能就是能够涵盖就是100米以内，它属于短距离应用。那当然我们有一些像是 LoRa 这种长距离应用，距离可以到达10公里以上。 但是它的输入部可能很低，可能就是10K、20K 甚至100K 而已。那 Morse Micro 所提供的 WiFi Halo 晶片，它就是可以取其中间的平衡点。简单来说，我们可以做到 WiFi 10倍的远距离。那但是我们也同时又可以提供 LoRa 1000倍以上的频宽，这是 WiFi Halo 这个技术所能够做到的一个水准。那这是几个我们在全世界所做的一些实际上测试的状况。比如说我们在美国的一个国家公园，就是我们在一个完全没有干扰的环境下面那可以做到将近15.48公里。在这个条件下面，我们还有达到2到3 m 的频宽，这是在一个无关，就是我们可以验证一下理论状况。这是一个在最干净的情况下，我们可以达到一个距离以及频宽水准。那当然，我们也回到了一个实际一般比较正常使用者可接受的环境。那我们在澳洲的一个海湾，那我们也做了一样相同条件下，用相同的 equipment 做了相同的测试。那在这个条件下面，我们可以达到4公里远。那同时还要保持 MHz 以上的一些输入部。那当然，刚刚提到了最干净以及一般正常使用情境下面，我们也回到了号称全世界在 CES 秀里面这是一个最环境最嘈杂干扰最多的情境下，在这个条件下面，传统 WiFi 基本上几乎可能传输距离可能10米、20米，可能就会断线或什么的。在这个前提下面，我们还可以达到510公尺，而且能够提供到将近2 Mbps 的输入部。那提完了一些实际的测试，那我们当然调到 user case。那 WiFi Halo 非常适用于在video streaming 这样的 application， 包含了一些摄像头啦、camera 啊，无论是 indoor camera、outdoor camera。那无论如何，它可以提供一些更低的功耗。相对有一些 camera device 是使用电池的，那它就非常适合在这样的条件下去做一些应用。那相较于 Legacy WiFi 传统 WiFi， 它可以提供将近100倍的那个涵盖范围。那当然，它可以提供足够的频宽去支援一些high resolution HG 的一些影像。最后当然就是一些我们因我们使用的是900 MHz 的频率。所以它可以相较于传统 WiFi， 我们可以得到更好的穿透力，去 cover 更大的远距。那针对建筑当然一样，建筑提到就是一些如何去涵盖我们的环境。那因为建筑有楼层你需要穿墙、穿楼层等等这些东西。那 WiFi Halo 因为它运行在Sub-1 G，所以它非常适合应用在这样的一些环境里面。那当然因为我们的涵盖距离，所以我们可以节省一些基础架设的一些方式。我们可以用更精简的数量去部件以及涵盖我们所需要的一些控制范围。那当然，穿透性就是一个非常需要被讨论的一个必要条件。毕竟你在建筑里面，你可能需要穿的不只是楼层，甚至还有很多的一些建筑环境的一些障碍。那最后，安全性这是必须被考量的。我们支援 WiFi 联盟所定义的 WPA3， 那这个可以确保我们的安全，我们资料不会外泄。那工业应用来讲一样，不免俗还是提到就是 cover， 我们怎么涵盖，我们怎么去覆盖我们需要的涵盖距离。WiFi Halo 因为运行了一些 Sub-1 G 更低的频宽，所以基本上它可以覆盖更远的距离。当然在工业体系里面穿透性也是需要被考量的，所以基本上。无论是距离也好，穿透性也好，都是需要都是我们在这个环境下面能够胜任的一些条件之一。那无外乎的刚刚提到的就是安全性、IP， 甚至到最后我们提到这些无论设施也好，你偶尔总是需要做一些软体的更新。那因为我们提供相对足够的频宽，都适合这些装备做这些相对的更新。那最后就是仓储，那一样，其实我们提到都是一样的状况。如何在你的条件使用情形下，用更大的覆盖距离以及更好穿透性去 cover 这些应用情境。那 WiFi Halo 就是相对于这些东西，我们可以提供更好的远距离特性、更好的穿透性，然后以及刚刚提到更多的节点。那这对仓储应用来讲，就是一个非常适合使用的一个条件。那以上是我的报告。那我是 Frankie from Morse Micro。 那如果对 WiFi Halo 有任何兴趣，也欢迎大家来找我。那同样，我们有客户在 Computex 做了一些成品的展示，也欢迎大家来找我，或者是找我们客户来讨论 WiFi Halo。谢谢大家。
Thank you, Mr. Young. Lastly, we would like to introduce Mr. Alfred Wu, Director of Sales of MILLIBEAM, to share about millimeter wave chipsets.
Hi, I'm not Alfred. Alfred is sitting in the audience. My name is Venkata. I'm the founder and CEO of MILLIBEAM. MILLIBEAM is a company based in Sydney, Australia. We are a fabless semiconductor company, meaning that we design our chips, we test them, but we don't fabricate them. These chips are made in countries like Taiwan or places like Europe. But what we do is that we have all the IP in the chip itself. So what we basically are building is a world's best semiconductor solutions for low-cost wireless networks and systems. I'll explain what that means. Radios are at the heart of everything that we use today. They are in the mobile phones, they are in laptops, they are in base stations, Wi-Fi systems, so on and so forth. And radios have been built a certain way, and the focus has always been on performance and cost. But the communication standards that are coming in are changing a lot of things. And that means that how we build the systems, how we build these chips is going to mean whether the end system is going to be expensive or low cost. For instance, most of the standards that we look at today, like 5G, has multiple frequency bands. What that means is that you have a band at 3 to 4 gigahertz, and you have a band between 26 to 29 gigahertz. And these bands are spaced far apart. So for each of the band, you need a different base station. So that makes it more expensive. You need a different hardware, so on and so forth. And the second thing is that because low frequency bands, the bandwidth is limited there, the frequencies that are being used are going to higher and higher frequencies. But the downside is that the signal range decreases. You might get a higher data rate, but the signal range is a lot less. That means you need more and more base stations. So in a smaller geographical area, you need more base stations, increase the cost as well. And secondly, because of the limitations of semiconductor technology, the energy efficiency of the chips is also very low, which means that you need a lot more electricity costs as well. So when you put all these things together, your chipset cost may be very low, but your overall system cost is very high. And that's exactly what we're doing. What we're building is not a cheap chip that is not raised to the bottom, but actually trying to address some technical problems that would result in a base station or a network that's actually cheaper. So a technology we're building has many use cases, like 5G and 6G. Our technology can enable a 10-time reduction in cost of a 5G network. And the same thing can be used in satellite relay networks that uses 5G standard as well. More importantly, nowadays, there's a lot of dual use systems, meaning that autonomous platforms that are used for communications, other kinds of purposes as well. What we're building, because of the chipset energy efficiency, can actually increase the range of these autonomous platforms. So this is the scope of our market. Our technology has very wide use. Because it's a radio technology, it could be used in pretty much all applications of radio. So as such, the market scope is pretty big. It exceeds many tens of billions of dollars a year. The markets on the left are high volume markets, and on the right are a relatively low volume but highly profitable markets. So I just want to go back a little bit to a use case like a 5G or a 6G that's coming up soon. So one of the things that's happening is that there's been a movement more and more to higher frequencies, so which results in, for instance, millimeter wave bands are used more often nowadays. And secondly, you have multiple bands that are next to each other. So radios are not built in a way to support two different bands that are next to each other. You need to have two different radios for that. And secondly, what are called the modulation schemes used to support these radios are also changing, which results in difficulties such as you need to deal with non-line of sight links, meaning that the base stations can't see each other. There's a buildings or trees in between. And secondly, you need multiple radios, and also energy efficiency is a problem. So if you look at a base station that is based on millimeter wave frequencies, you need a separate base station for different frequencies. You have a coverage that's less than 100 meters, and you have energy efficiency 3%. So what this means is that 97% of the energy that you supply to the base station is wasted as heat. And more importantly, the base station has only a range of 100 meters. So all of these things result in an extremely expensive system. So it doesn't matter, your chipset cost is very low, your system cost is very high. And the second thing, if you look at a mobile handset, there are multiple chips for each band. And also, a lot of chips are there as a redundancy built into it, not necessarily that they're doing something different. Because of this, you have space constraints and the poor batteries, and so on and so forth. Again, the key point being that you could have a really cheap chipset, but the performance not being there means that you end up with a system or a device that's not so good. So we built a chipset platform that actually addresses these problems. Basically, what we do is in a single chipset, we support multiple bands that are both millimeter wave and low frequency bands as well. Which means that with a single radio, you can build a base station that operates at multiple bands. And we have a very high output power, which is long range. And secondly, we have the world's highest energy efficiency as well. All of these things mean that we can support a reliable millimeter wave link that was not possible before. And also, we have a low system cost of 10 times, a fraction of the cost what it used to be. So for a number of these use cases like macro cells, small cells, and fixed wireless, and also handsets, we have a number of products that we're building as well. So just want to go a little bit look at the emerging applications like dual-use autonomous platforms. In this case, the UAV requires to have multiple capabilities, meaning that it needs to support radio functionality, it needs to support radar functionality, so on and so forth. So meaning that you need to have a radio that operates at multiple frequency bands. So that's exactly what our technology does. Besides that, our chips are also very high energy efficiency, meaning that it can allow the UAV to be in the air for longer periods of time. So in this way, the chipset technology we're building can support upcoming dual-use autonomous platforms as well. Again, we have a chipset for that too. Exactly does the same things, but supports particularly for this use case. There's a number of solutions we are releasing the market towards the end of the year for these dual-use solutions, supporting SATCOM arrays, UAV platforms and radars and so on and so forth. We built a team of 25 people. Not everybody shown here. Most of the people have worked in fairly large companies like NXP, Huawei, Canon, Samsung, and so on and so forth. There's a lot of expertise here. More importantly, there are a lot of innovative engineers here. So we also built a ecosystem or a partnership pipeline. We have investors, quite well-known investors as well, and also semiconductor foundries that are working with us, as well as the EDS software providers, and also test solution providers as well. We are here in Taiwan because we came here a year ago, and we found that there's a big ecosystem here, and we want to tap into that. So we are here back again, and we also, like they said before, Alfred Wu is based in Taiwan, so we will have a continued presence here. So hope to see you back, hopefully at this forum or the next sometime again soon. Thank you.
Thank you, Dr. Guda. So that'll wrap things up for today. If anyone's interested in New South Wales Pavilion, make sure to visit their booth in the next 3 days in InnoVEX. And that'll wrap things up for the Pi Stage programs for today, and hopefully we'll see you tomorrow. Thank you.